Hello friends, let's start with thermal stresses. Okay, so thermal stress, it is the stress which is getting generated due to change in temperature. Okay, so there are two necessary essential conditions to have thermal stress. The first one, there should be a change in temperature. The second one, there should be a restriction to the expansion. So these two cases are mentioned over here. Okay, so these two cases are essential to have thermostresses. Okay, now thermostresses can be studied by using the following three conditions. The first condition will be a condition of free expansion, second condition will be fully restricted condition, third condition will be partial expansion. Before going for this condition, what we will do, we will just try to calculate the change in length in case of thermostresses. Okay, now let's assume there is a rod, and if it is heated, as it is made up of engineering material, as soon as we will provide a heat to this rod, what will happen, it will try to expand. So if there is expansion, so this will cause a deformation. So to calculate this deformation, let's see how to do it. Okay, so to calculate this deformation, we will use certain terms. So to have it, see, alpha will be mentioned in the problem. Alpha is nothing but your thermal coefficient of expansion. Okay, so it will be different for different material. For steel it will be different, for the aluminum it will be different. So thermal coefficient of expansion is nothing but it will give us the idea about the expansion which will occur in the material. Okay, so let's say alpha for steel, if it is less than alpha for aluminum, what will happen, for a particular constant change in temperature, aluminum will expand more as compared to steel. So this is the significance of alpha. Now alpha will always be given whenever we are dealing with thermostresses. Now what is the unit of alpha? It is per degree centigrade. Now this delta T will be in degree centigrade, and it is nothing but a change in temperature. L will be the original length of the rod or bar which we are taking into account. Okay, so if I multiply this alpha, that is nothing but thermal coefficient of expansion, with change in temperature, I will get a dimensionless quantity. And one more thing, the strain is nothing but our dimensionless quantity. If we compare these two dimensionless quantity, we will get strain equal to alpha delta T. So strain is nothing but change in length upon original length. So from this, our change in length will be equal to alpha into delta T into L. Okay, so you have to keep this equation into mind to understand the following three conditions. Now let's come back to these three conditions. The first condition will be free expansion condition, second condition will be fully restricted condition, and then there will be a partially expansion or partially restricted condition. In free expansion condition, to have thermostress, we must have the change in temperature and restriction to the expansion. Now in free expansion condition, our second condition is not getting satisfied. If it is not getting satisfied, means stress will be 0. What about strain? See, to have strain, there must be change in length. Now whenever we will heat a bar or a rod, what will happen? It will expand, and if there is change in length or expansion, we can calculate the strain value. So in free expansion condition, stress will be 0 and strain will be there, and in this case the strain will be given by alpha delta T. See, this alpha delta T we have already discussed over here. Both are dimensionless quantity, so strain will be there. Okay, and in this case the deformation will be, strain will be equal to change in length upon original length, so deformation will be equal to alpha into delta T into L. So please keep a note of this thing. Whenever we are trying to talk about free expansion, stress will be 0 and strain will be equal to alpha delta T. Let's try to talk about second condition. Second condition is fully restricted condition. Now here, from both the ends, rod is fixed between rigid support. And now if we try to change the temperature of this rod by providing the heat, as soon as we will provide a heat, the temperature will increase, and with the increase in temperature the material will try to expand. But as it is fixed between two rigid support, it will not be allowed to do so. If we are not allowing this rod to expand, what will happen? We want two conditions, or we need to talk about two conditions. There will be a change in temperature. The second condition of restriction will come into picture in this fully restricted condition. Now, due to change in temperature, the material would like to expand, but it is not allowed to do so due to the rigid support. And if there is restriction, this restriction will cause stress. So in second condition, stress will be there. Okay, now how much it will be, that we will discuss within 2-3 minutes. Okay, now the restriction will cause, the restriction which is there will cause no change in length. If there is no change in length, means strain will be 0. Is it okay? Now how to calculate this stress value? To calculate the stress value, the deformation which will be restricted will cause stress. Okay, now the rod is trying to expand up to this position, and this much of expansion is getting restricted. If this much of expansion is restricted, this will cause stress. So if I try to talk about this value, restricted value, it will be alpha into delta t into L, and this is the deformation which is restricted. If I compare it with PL by AE, I will get the stress value. So stress value will be equal to alpha into delta t into E. Is it okay? So in fully restricted condition, stress will be there and strain will be equal to 0. So how much amount of stress will be there? It is alpha into delta t into E. Now let's try to talk about the third condition. The third condition is partially restricted condition. Before applying this condition, please keep a note of one thing. The free expansion of the bar or material which we are taking into account should be greater than the space provided. Okay, it should be greater than the space provided. Why I am saying this? If your free expansion of the material is less than the space provided, what will happen? The material will be allowed to expand freely, and this support will not come into picture. Okay, so if free expansion is less than the given space, what will happen? It will be the case of free expansion, and it will not come under the category of partially restricted condition. So to apply the partially restricted condition, your free expansion should be greater than the given space or provided space. Okay, then we will be able to apply the partially restricted condition. Okay, now in this case, please try to understand. Alpha delta TL is nothing but your free expansion. Minus delta is nothing but the space which is provided. Now subtraction of this will cause, see, alpha delta TL is nothing but a free expansion. Okay, so rod would like to expand up to this position. Now due to support, it is allowed to expand up to this point only. It is allowed to expand up to this position. So the remaining deformation will cause stress. Remaining of deformation will cause stress. So this deformation will be equal to stress. Okay, so this restricted deformation is nothing but alpha delta TL minus delta. Okay, and this will be equal to change in length, and this change in length will cause stress value. Okay, so if we calculate the stress by equating it with PL by AE, we will get stress as, thermal stress as alpha delta T into L minus delta into E by L. We just have to transfer the values from right hand side to the left hand side to get the answer. Now what about strain? Strain will be nothing but change in length upon original length. कितना change in length restrict हो रहा है? That is nothing but alpha delta TL minus delta. Is it okay? And how much is the original length? Original length is L. So strain will be equal to alpha delta TL minus delta upon L. In other way, we can say stress is nothing but alpha delta TL minus delta into E by L. Now we know one thing, stress is nothing but strain into Young modulus. So this strain is nothing but this value. So strain will be equal to alpha delta T into L minus delta by L. So in partially restricted condition, both stress and strain will be there. Okay. So now be there. Okay. Now let's take an example, simple example. A steel rail is 12.6 meter long and is laid at a temperature of 24 degrees centigrade. So when it was laid, the temperature was 24 degrees centigrade. The maximum temperature is expected to be 44 degrees centigrade. So how much will be the change in temperature? Change in temperature will be the maximum temperature minus the temperature at which it has been laid. So it will be equal to how much it will be? It will be 20 degrees centigrade. Is it okay? Is it okay? Now estimate the minimum gap to be left between two rails so that the temperature stresses do not develop. So our first condition is we need to estimate the gap between the rails so that temperature stresses do not develop. When the stress will not get developed? When there is a case of free expansion. So our first answer will lie with our first case, and our first case will be free expansion. So whenever there is a free expansion condition, stress will not get generated. So you have to keep this idea in your mind how these three cases are getting applied, and by applying these three cases we can solve any problem related to thermostasis in a single bar. Okay, so if we try to apply the free expansion condition, your stress will be equal to 0. What about strain? What about strain? Please try to have a look. This is our free expansion condition. So in free expansion condition, stress will be equal to 0, whereas strain will be equal to alpha delta T. Okay? So strain will be equal to alpha delta T. Now what we have to calculate? We just have to calculate the minimum gap to be left. Minimum gap means it will be a deformation, free amount of deformation that we are allowing. Okay? So strain is nothing but change in length upon original length. Okay, so change in length will be given by alpha into delta T into L. Now in this problem statement, alpha is given as 12 into 10 to the power minus 6. How much is the change in temperature? Change in temperature is nothing but 20 degrees centigrade, where into your length. How much is the length given for a bar? It is 12.6 meter. For a rail, the length is given as 12.6 meter. We will convert it into mm. So it will be 12.6 into 10 to the power 3. So if we try to calculate this answer, it will be 3.024 mm. So if we are providing a gap of 3.024 mm for a single rail, what will happen? No thermal stress will get generated in this case. Okay, so this will be our first part. Now let's try to go through the second part. Calculate the thermal stresses developed in the rails if, what is our first condition? No expansion joint is provided. Now if there are no expansion joint provided, means there is a direct contact between two rails. If there are direct contact between two rails, means no expansion gap is provided between two rails, or there is no gap between them. That's why it will be a condition of fully restricted condition, or it will be a second condition, that is nothing but fully restriction. If there is full restriction, what will happen? In case of full restriction, as we have discussed earlier, in case of full restriction, stress will be there, and what about strain? Strain will be equal to 0. So whenever we are getting such kind of problem, first of all implement your conditions. In your conditions only your answer will lie. Okay, so no expansion joint is provided means strain will be equal to 0. What about stress? What about stress? In this case, please try to see in the second case, that is nothing but fully restricted condition. What will happen? Stress will be equal to alpha delta T into E. Alpha delta T into E. Alpha into delta T into E. If we try to calculate again, alpha will be equal to 12 into 10 to the power minus 6 per degree centigrade. The change in temperature will be 20 degrees centigrade into What will be E? E is given in the problem statement, that is 2 into 10 to the power 5 MPa or Newton per mm square. If we try to calculate the stress value due to fully restricted condition, then that answer should be equal to 48 Newton per mm square. So this will be the stress value in case of fully restricted condition. Now see, a rod was there, it has been heated to have a, or rail was there, this rail was heated up to how much temperature? To have a change in temperature of 20 degrees centigrade. Now if it is allowed to expand freely, it means there will be a free expansion of 3.024 mm. Is it okay? Now in second case, what has happened? This restriction was totally rejected. If this expansion is totally rejected, means this 3.024 mm will cause stress. Is it okay? And that stress is nothing but due to 3.024 mm restriction. Are you getting my point? Are you getting my point? Now if we try to go for the third condition, please try to see the third condition. What is the third condition? If a 2 mm gap is provided for expansion, कितना बढ़ना चाहता है? 3.024 mm. लेकिन हमने गैप कितना प्रोवाइड किया है? 2 mm. It means your delta is less than the free expansion condition, and that time we will apply the third condition. And what is that third condition? We will get stress value as well as strain value. And what has been asked in the problem, please try to see. Calculate the thermal stress develop in the rails if a 2 mm gap is provided for expansion. Is it okay? Is it okay? So कितना बढ़ना चाहता है? 3.024 और गैप कितना दिया हुआ है? 2 mm. So how much amount of deformation will cause stress? 3.024 minus 2 mm means 1.024 mm will cause thermal stress. Is it okay? So this sigma will be thermal stress. Okay? So this thermal stress can be calculated by this way, or otherwise we can apply that formula directly, and that formula is nothing but alpha delta TL minus delta into E by L. So stress can be calculated directly. This stress calculation will be alpha into delta T into L minus delta into E by L. So by using this formula also, direct formula, we can solve the problem. By both the ways, your answer will be same, and this answer will be equal to, stress will be equal to 16.254 Newton per mm square. Now please try to understand, whenever there is a fully restricted condition, how much amount of restriction is there? 3.024 mm of restriction, and it will cause a stress of 48 Newton per mm square. Whenever the restriction was less, stress कितना होगा? जितना restriction कम है उतना stress कम होगा, and that's why the stress will be 16.254 Newton per mm square. So maximum thermal stress which will occur, maximum thermal stress will occur in case of fully restricted condition only. Now let's try to approach the problem, third part of the problem. Okay, if the stress developed is, there are some slight printing mistake, so let me see the question. If the stress developed is 20 MPa, what is the gap between the rails? Now the question has been reversed. Okay, so what you have to do, a stress is given, based on the stress you just have to calculate the delta value or gap between the rails. Is it okay? So see, 1.024 mm, if it is 1.024 mm of restriction is there, how much amount of stress is getting generated? 16.254. So now the problem has been reversed. 20 Newton per mm square of stress is getting generated. How much should be the restriction? That we have to calculate. Now to calculate this thing, we will directly go by the formula. Okay, so this is our first problem. So we will directly go by the formula. Stress is nothing but alpha delta T into L minus delta into E by L. Now in this case, the stress is given as 20 Newton per mm square. Now we know one thing, the free expansion will be equal to 3.024 mm. Delta we have to calculate because the gap has been asked. Okay, E is given to us. E is 2 into 10 to the power 5. What about L? L is 12.6 meter. Is it okay? If we try to solve this problem to get the delta value should be equal to 1.764 mm. Means how much restriction is there? 3.024 minus 1.764. So this much amount of restriction will be there to have a 20 Newton per mm square of stress. Okay, is it okay?